I'm going to do 2 examples of exponential growth and decay word problems, explain a little bit of stuff to you guys so that you can work on the rest of this. So let's look at number 1 here. The world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.26%. So for the first thing, we want to find the growth factor for the world population. So to find the factor, we need to take our rate, write it as a decimal, and then add 1 to it. Because it's growth we are adding. So first thing I'm going to do is I'm going to take 1.26%. I'm going to rewrite it as a decimal, which means that I take my decimal point and move it 2 over to the left. So that is going to be 0.0126. And now I want to add 1. So 1 plus 0.0126 equals 1.0126. That is my growth factor. So suppose the rate of increase continues to be 1.26%. Write a function to model the world population. When I use this 6.8 billion, I'm going to leave it as 6.8. So f of x equals 6.08 times 1.0126 to the x. Let x be the number of years past the year 2000. Find the world population in 2010. So since x is in the year 2000, 2010 is, it's been 10 years, so x is 10. So I'm going to plug in f of 10 equals 6.08 times 1.0126 to the 10th power. .08 times 1.0126 to the 10th power. And so I get 6.89. So that is 6.89, and again, that's in billion. Okay. I'm going to flip my paper over, and now I am looking at number 4. So it says, write an exponential function to model each situation. Find the value of each function after 5 years. So the reason that I want to do this problem is I want to talk to you about this. A $12,500 car depreciates $9 each year. Some of you may have heard this word before, some of you may have not, so I wanted to go over it. So depreciate. It does mean decrease. So the idea is when you buy a car, you pay however much that car is worth. In this case, the car costs $12,500. And from the moment that you take that car from the dealership, the car starts to depreciate, which means the value of the car decreases by 1% each year. And so this is a very real world specific problem. This happens all the time. So the car that I own, I bought brand new, and it continues to depreciate each year. And the depreciation of that is exponential. So it loses a lot of value in the first few years, but then the longer that you have the car, the less value it loses. With the idea that the car is never without some value. It is always worth something to someone. So when we do this, because depreciate means decrease, that means we're using the exponential decay function. So we are going to have f of x equals, our initial value is how much the car was initially worth, which is $12,500, and then inside it's going to be 1 minus 9% as a decimal is 0.09 to the x. Then again, we're going to rewrite this because we want to combine this 1 minus 0.09. So I'm going to grab my other pen. We're going to write, this is going to be f of x equals 12,500, and then in parentheses 0.91 to the x. Okay, a baseball card bought for $50 increases 3% in value each year. And this is also pretty accurate. Baseball cards do increase in value for the longer you have them. Not all cards, but some of them. So we're increasing, which means we're going to use our growth. So it's going to be a plus on the inside. F of x equals, our initial value is $50 times 1 plus 0.03 to the x. So that's going to be f of x equals 50 times 1.03 to the x. Now we wanted to find that the value of each function after 5 years. So I'm really quick going to go back and do that. So f of 5 equals, just using my calculator over here, and I get that to be about $7,800 after 5 years. And then here, 5 years after we buy the baseball card, that appears to be worth about $58. So you can see that the car lost a lot more value and the baseball card wasn't worth a whole lot more. But if you looked at how much that baseball card is going to be worth after 10 or 20 years, it is going to be significantly higher. Whereas after 10 or 20 years, this car won't have lost that much more. It's going to lose a lot in the very first year if we're talking about depreciation.